Find the square roots of unity and find the cube roots of unity. So whenever you talk about roots of unity, that unity is 1, right? So we're finding the square roots of -1, which hopefully you already know. It's one of them is -1 and one of them is 1. I'm just going to demonstrate it using complex number methods, and you should get the same answers. If we don't, we know there's a serious problem. So for part A, we're saying basically we're solving z squared equals 1, where z is a complex number. Okay, so if we think about the number 1, well, that's purely real. It looks like that. Goes to 1, that's the real and the imaginary. The modulus is 1 and the argument is 0. So z squared equals cis, where it's 0 plus k2 pi. Remember, if you don't include the k2 pi, then when you use De Moivre's theorem to find the square root of this, you're only going to get one answer. For a square root problem, there are 2 answers. Okay, so z equals the square root of this, so it's cis. And using De Moivre's theorem, well, it's 0 over 2 plus k2 pi over 2, so that would be k pi. The 2 pi over 2 is k pi. I should have mentioned as well, I've said it in previous videos, k needs to be an integer. The reason why this k2 pi works is because if you have this number here at 1, if I add 2 pi to it, I get back to the same place, and I can do this as many times as I want, as long as k is an integer, and k can be negative. I can add 2 pi and go backwards, and I still get back to the same place. Okay, so we now just need, for a square root problem, we need 2 consecutive integer values of k. So let k equal 0, so that would mean z equals cis 0, which is 1. Let k equal 1, z equals cis pi. So if we think about that, pi is over here, right? Could even draw a circle. That's pi, and you should know that cos pi equals -1 and sin pi equals 0. So z equals cos pi plus I sin pi equals -1 plus 0 equals -1. So z equals -1 or 1, which, as we said at the start, of course, that's the answer to find the square roots of unity. If you're solving to x squared equals 1, x equals plus or minus 1. So now we're going to do the cube roots of unity. Okay, so we're solving z cubed equals 1. So I'm not going to need the diagram because we already know that 1 is cis 0 plus k2 pi. So z cubed equals cis 0 plus k2 pi, or just k2 pi really. So that means z equals the cube root of that, so it would be cis k2 pi by 3, just like that. Don't forget, k needs to be an integer. Okay, so let k equal 0, z equals cis 0, and we already know cis 0 is 1, we did it at the start. Let k equal 1, z equals cis 2 pi by 3. Okay, equals cos 2 pi by 3 plus I sin 2 pi by 3. So pi by 3 is 60, 2 pi by 3 is 120. So that is over here. Okay, so the parent angle is 60, which has cos 60 is a half, sin 60 is root 3 over 2. So For 120, well, the cos is going to be negative, minus a half, and sine will still be positive, root 3 over 2. So z equals minus a half plus root 3 over 2i. Okay, so that is an interesting answer to the cube root of minus 1. And then we can let k equals 2. That means that z is going to equal, you've got 2 times 2 pi over 3, which is 4 pi over 3, so cis 4 pi over 3. Okay, so pi over 3 is 60, 4 pi over 3 is going to be, well, 4 6s are 24, 240 is down here, right? So that has coordinates. We can use what we've got already. Cos and sine will both be negatives. That is at minus a half and minus root 3 over 2. So that is going to be minus a half minus root 3 over 2i. Minus a half minus root 3 over 2i. Okay. Okay, so to solve the question, which looks so innocuous, z cubed equals 1, the 3 answers, 2 of them are complex, and do note that it's the fundamental theorem of algebra. If you have a complex root to a polynomial equation, then its conjugate is also a root. So once we knew that minus a half plus root 3 over 2i was a root, then the fundamental theorem of algebra actually tells you that the conjugate is also a root. So minus a half minus root 3 over 2i must be a root once you know this is a root. They are complex conjugates, and then the third root is 1, which I should put a box around. So the 3 answers to z cubed equals 1, or the 3 answers for the cube roots of unity are 1, minus a half plus root 3 over 2i, and minus a half minus root 3 over 2i.